Hello, good morning everyone. Today I am going to discuss about Unit 5 Part 2 File Management. Here we are going to discuss about some of the file manipulation system calls. The file manipulation system calls like create, open, close, read, write. So these are the some of the file manipulation system calls we are going to discuss now. Past classes we discussed about Korn shell programming. Now we see about what is a system call. So how to open a file, how to create a file, how to close a file. So by using a system calls, right. Here before going to the open, close, read, write system calls, we need to understand what is a system call. Already you might be studied earlier in C programming the basics about system calls. So once again I recollect here. So the definition of system call. System calls are a special set of functions available in programming languages. So in all programming languages, all programming means whatever may be the programming language you learnt at the beginning of your course. It can be C programming. Within a C programming we might be studied the system calls. Here again within the Linux programming we are going to study about system calls. Here system call means it is a special set of function available in programming language. So they are used by the programmers. We are using this system calls in order to communicate with operating system. We can directly communicate with our operating system. So and then operating system will communicate back to us in terms of a written value to our function, right? So here you try to understand when system call is invoked, so immediately it will switches your operating system switches from user space to kernel space, right? There is a user space. User space means where the user is going to work, where user programs are going to be executed. So when there is some function to be performed within the kernel environment, so in terms of a system calls, so we are switching from the user mode to the kernel mode within a kernel mode. So the kernel function, right, we call it a system call, is going to be executed. So once within a kernel mode executed, so here the operating system will return back some written value to the function, right? The first system call we call it as a open system call. Here the syntax for open system call is fd equal to open. There are three arguments are going to be passed. One is a path, flags, and modes. So where path is a file name, here we are going to give a path name. A path name can be an absolute path name or a relative path name. So in this path name there will be a file. Here we are trying to open that particular file which is present in your current directory or which is present in some other directory. So if it is present at some other directory, so we are giving a path name from home directory, right? If it is present, right, file is present in current working directory itself, we are going to give a direct file name as a path. So we call it as a relative path name. So and then we have a flags, right? Flags indicate a type of open. So we are opening a particular file for the sake of read or write, right? So and then we have a modes. Modes gives a file permission if the file is being created or the file is being opened. So when the file is opened, so what sort of permissions are applicable for corresponding file, whether file is having a read, write, execute permission for the owner, for the other category, for group category, right? This is about three parameters which are supplied for open system call, right? Coming to the FD indicates that it is a user file descriptor. So the user file descriptor will return an integer value. All right. So we'll see about this file descriptor in coming slides little bit more. Coming to the required include files. So what are the include files which to be maintained whenever we are using open system call within our program is hash include systype.h, as include systat.h, as include fcntel.h. So these are the default header files to be a part of your open whenever we are using a open system call within your program, right? So and then coming to the second parameter, we call it as a flag. All right, so we are opening a particular file for the sake of read only or for the sake of write. What is the purpose here, right? So here within this flag, so the flags like o underscore rd only. So meaning of this is we are opening a file so that it is ready for read. All right, so we are reading a particular file for the sake of read, right? So and then o underscore wr only means we are opening a file so that it is write only. All right, so write only permission is applied, right? So o underscore rdwr, right, we are opening a file for the sake of read and write, right? We can perform both, right? O underscore append, so in order to append at the end for existing file, so o underscore create, the file is not available within the path which we specified, so we are trying to create another new file, right? So whenever we are trying to create o underscore create, right? So these are the flags which is a part of your parameter for open system call. So and then coming to the modes, right? So here the modes are set of permissions for all the three category of users. So for owner, what sort of permissions are applied? Read, write, execute permissions, right? So if owner is having a read, write, execute permission means we need to include the modes like this s underscore I or usr, meaning is set read permission for the owner, s underscore I wusr, set write permission for the owner, s underscore I x usr, set execute permission for the owner. So in this way we are including modes for owner. All right, so and then coming to the another three modes for the group category, s underscore I or grp group, set a read permission for the group, s underscore I w grp, set the write permission for the group, s underscore ix grp, set execute permission for the group. So these are the three permissions which we like to set for group category. So and then coming to the other category, s underscore I or oth indicates that other category, s underscore I w oth, set write permission for other user, s underscore I x oth, so set execute permission for other user. So these are the permission set for three category of users which is a part of a parameter within a open system call, right? Coming to the system call, the C syntax for system call, open system call is like this, right? The header files already said hash include systype.h, hash include systat.h, hash include fcntel.h, integer type open, constant character, right? Star path name. So here we are trying to give a path name. It can be a relative path name or it can be an absolute path name. So int flag, integer type flags. So flags indicates that so we are opening a particular file read only, write only, or both read and write. So for this particular reason, so we can pass only 2 parameters, we can pass the 3 parameters also. So if the 3 parameters are passed to open system call, so here so additionally we can see mode underscore t, it is a data type for mode underscore t is a data type for mode, what mode to be present for 3 category of users, for owner, for other, for a group, right? So coming to the Unix file system, you try to understand. So whenever we are opening a file, so there is some structure, all right? So there is some data structure we can see. So at the background the things will happen, we are not identifying. So only the thing is we are writing as a code, so we are trying to execute that particular code, we are going to see the result, but the background certain things are going to happen. What certain things we'll see here. So here try to understand, take for example within our program. So I have a statement, fd equal to open file a comma flags, all right? So here read the fd, all right? I'm reading the file a, I'm reading the file a, all right? So here fd is pointing to the user file descriptor table. So within a PCB, process control block, right? So there is integer values, right? So 0, 1, 2, 3, 4, 5, like this. So here within this user file descriptor table, so the first entry 0, it indicates that standard input. We can say that it is a redirection, right? Or we can say that it is a standard streams, stdin, for getting input from a keyboard, or getting an input from a file for a command or for a program, right? For a command or for a program, getting an input from a file or a keyboard. So here we call it as the standard stream, we call it as a 0, stdin, right? So standard out. So here the standard out, the file descriptor for standard out is a 1. So here 1 indicates that the standard stream std out. So whenever the command is executed, it will produce a result on the screen, all right? Result on the screen means we call it as a terminal, all right? Here the result can be written onto the file also. The result can be written onto the file also. So here if the result is if the command is writing the result on the terminal or to the file, so this stream we call it as standard out. The file descriptor value for the standard out we call it as 1, all right? So the standard error stream, there is another stream we call it as standard error. So whenever the command is produces some result, and then when the command is not executed, it is producing some error. So the error is going to be reported with the file descriptor value 2, all right? So the error will be reported with the file descriptor value 2. So error is going to be reported for your standard output stream, we call it as monitor, right? So these are the 3 streams, we can say standard in, standard out, standard error. So here the file descriptor value 0, 1 and 2 is already defined. So after this, so we have a 3, 4, 5 like this continuously. So here the next file descriptor value will be assigned for our program whenever we are using the file descriptor within our program. So the first file descriptor will be assigned with 3. So if another file descriptor is used, means so it is going to have a value 4. So if another file descriptor value is going to be assigned, means it is going to use a value 5. So like this. So the file descriptor value for open system call here is means here the file A is using a file descriptor 3, right? So when it is using a file descriptor 3, so it is pointing to the file structure table, right? So within a structure table, we can see the inode number